All right, welcome to my SPED talk. I'm Josh Staples. I'm going to be presenting on using Docker. Um, for my final project, I built a website, but in order to learn Docker, I actually did it for data science. So this tutorial will follow how to use Docker in a data science setting. So to get started, um, we're kind of going to skim over a lot of the installation just because one, there's a ton of tutorials out there that'll help you do it. And two, it can take a really long time if I try and talk through all of the installation instructions. So basically, high level, if you're on Mac OS, just download Docker Desktop for the right operating system, open it after installing it, open a terminal, you're good to go. Windows, a little more complicated. You'll need to install WSL if you don't. Maybe Windows Terminal, which is what I would use if I were on Windows. But then the rest is all the same. Just download Docker Desktop after you have those installed, and then open up Windows Terminal, and you can run all your commands in there. So to get into it, after you've done, you can check your install. I can show you that I have it installed over here too. You can run Docker PS. What that'll do is it'll print all of the currently running containers. I do have one currently running, which we'll get to in a sec. Docker version will print the version you have, and Docker run hello world is a image that comes with Docker. It'll just confirm your installation. And then this whale say is a Docker image this guy created, and it creates a little ASCII whale that will say hello there. And so all these are included in the GitHub repo. I can post that as well in this discussion board if you want to check that out. But yeah, so after you've checked your install and everything's working, then great. We'll get into the rest. If it's not working, I would recommend just Googling the errors you've had. Docker is pretty popular, and when I was setting this up, I ran into a few errors, but just by Googling the error, a lot of people have had the same thing, and so you'll be able to get it worked out in no time. So high level, what is Docker is what we're going to talk about briefly. Before Docker was really popular, the big thing would be virtual machines. And I'm sure most of you watching this might have an idea of what a virtual machine is. But the basic gist is, say you have a program that can only be run on Linux or can only be run on Windows. In the past, you would just create a virtual machine that would run Windows or Linux on Mac or vice versa. In order to be able to run this software or develop in a specific environment or what have you. Docker came along, and the reason Docker is so popular is because what it does is kind of the same thing, but it creates something that's a lot more, one, lightweight, and two, fast and less expensive. So the idea is that Docker runs off of a bedrock of Linux. That's why to install for Windows, you have to have Windows subsystem for Linux, because all of Docker is creating these tiny little virtual Linux machines, essentially. The big difference, though, is that when you create a virtual machine, you have to create all of the components that it needs to run the full operating system, right? You need graphical interfaces, you need all of the processes that need to run when you first start it up, you need everything to keep, like auto updaters, everything needs to be installed. And it can take up a lot of space. And typically, if you ever allocated stuff for a virtual machine, you know that it can take up a lot of memory and it can take up a lot of compute. And we don't want that. Docker, on the other hand, is a lot smaller because all it does is it downloads the bare minimum required to run just the libraries and packages that you're telling it needs to run. For example, if you wanted just Python and a couple libraries, you would specify just those, and it would build what's called an image, where that whole image just contains a little Linux machine that has Python on it and those libraries, and that's it. It doesn't have any graphical interface. It's all just through the terminal. And so it's a lot faster and it's a lot less expensive. So Docker also solves the problem. I don't know if you've ever experienced this, but if you've ever followed along like a YouTube tutorial or just something on Stack Overflow that you found and you copy pasted it exactly how it was written, the old Control-C, Control-V, you know, it's not working out for you. You're still getting errors. And you might have said like, well, it works for them, why doesn't it work for me? I know I've been there at least. And the biggest reason is because there's a ton of reasons that it could not work for you. You could be on different operating systems and install different dependencies. You could be running different versions of the dependencies that they installed versus what you installed, and things could have been depreciated. There's a whole myriad of reasons why. So Docker was also created to kind of fix that problem. When you create a Docker image, it will always have that same version of Python, that same version of the libraries. And so if you ever send it to someone, it contains all of the versions required to run. It kind of eliminates that need for, if you've ever posted something on GitHub and you have to do the requirements.txt and list all the libraries that they have to install and like the exact version, we can get rid of all of that by using Docker. So kind of moving on, images and containers you'll hear a lot when Docker is referenced. So images, I kind of touched on already. You create an image, it's the overarching kind of higher level, and then a container is created from an image. So here's a couple of analogies. A sandbag might be considered an image, and a sandbox a container, or a blueprint, you could say, is an image. Whereas a container might be that blueprint realized, right, built. And for all those object-oriented programming fans out there, you could say that an image is like a class, and a container would be an instance of that class. Say you're writing Java and you write new whatever, that would be your container. So why Docker for data science specifically? Well, data science, there's a lot of different languages, right? You could code in R, SQL, Python, Scala. There's a ton of different things. And each of those has a ton of different packages. And you might not want to bog down your computer with downloading all of that. And so you could download it all just in a Docker image. At the same time, also, data science is really integrated with pipeline development. So from data munging to machine learning model, all in one fell swoop, they like it all kind of containerized. And Docker does a really good job of that. You can containerize your entire machine learning process into one image, and then that can be deployed wherever you need it to be. So the basic workflow in Docker, we're going to go into this a little bit later. We're going to skip a few of them, but so we talked about images and containers. Build is the basic command if you want to create your own image. So if you have a file that you built and some dependencies, you can use Docker build to create your own image that you can share or post to Docker Hub. Docker pull, what it does is you can go to Docker Hub here and you can see that there's a bunch of people that have already made images. Say you want like a Python image, here you go. You can do Docker pull Python and it'll include whatever it says in the documentation on Docker Hub. And you can usually find an image that has all the stuff you're looking for without needing to create one of your own. So Docker pull will download all of that from Docker Hub onto your local computer. Docker run is what we're going to use in this example. Docker run, what it does is it runs an image once you've downloaded it so it can create a container. Yeah, there's a bunch of flags that you can pass to a lot of these too. I'm not going to get super into that, but if you want, you can read the docs and look more into that. And then finally, you have Docker push. So if you did do Docker build and you built your own image, then you want to share it on Docker Hub, you can use Docker push to push it out to the World Wide Web. Pretty similar to GitHub or Git, if you've ever used Git. They're very similar commands. So finally, we're going to get into the image that we're going to use for data science. So this is an AllSpark notebook, is what it's called. And if you go to this, it'll bring you to the Docker Hub link. So basically what an AllSpark notebook is it's Python, R, Spark. I think it also has Scala in here. And then just a ton of libraries for each. I know it includes pandas. I know that for Spark, it includes like PySpark SQL and PySpark. So it has a ton of stuff. It is about 4 gigs. So when you run this Docker pull, if you're following along, be prepared. If your internet's not super fast, it could take quite a while. So just make sure that you are aware. It took me a while. So the basic idea for what we're going to do is first you want to navigate to the directory that you want to use all of these in on your local machine. This is super, super important because what we're going to end up doing is we're going to mount that directory to a directory inside of this container. So anything that you create in the container will be saved into whatever directory you mount it to. And so you also may not want to give your entire computer's access to this container. And I think that's just best practice for most Docker containers if you're ever mounting. But so first, navigate to the directory you want to use. I have already done that over here. We navigated to the directory that I have here. Just Docker example, I created a folder in one of my classes. So we're gonna do all of our coding inside of that directory. So navigate there first. Then if you haven't already, run the Docker pull Jupyter Allspark Notebook. That'll start downloading the Allspark Notebook image. And once that's done, you can go ahead and either run step 3 or step 4. And we're going to go a little bit more in depth about what these do because there's a ton of flags and it looks super long and scary, but it'll make a lot of sense. So I'm on Mac, so I'd run the top one. They're almost identical except for just this part on both of them. And it's just a syntax thing. But on Mac OS and Linux, we'd run Docker run, and then we'd do this -it. -it, what that flag does is it essentially creates a integrated terminal. So like a command window if you're on Windows or a terminal on Mac, it creates one of those inside of your container so that you can run commands inside of the container instead of running them all on your local machine. That's super important, one, because what Jupyter Notebooks do is start up a server to host our notebook, and we want to be able to close that eventually, as well as you might want to run other commands in the terminal inside of your container. Continuing on, we have this --rm. What that's going to do is it will automatically delete the container once you kill the server and close out of all of it and stop Docker. So this is nice. You can not include this if you want, but I think it's a good idea to clean up after ourselves after we've created a container. You don't need to keep containers after you've created them because we're mounting a personal directory to this container. All of the work that we're going to do inside of it will be saved locally. So you don't have to worry about it deleting if you remove the container. But I guess it's personal preference, whatever you want to do. The -p flag, what this is doing, it's kind of getting into networking. We're not going to go super deep into it. But again, what this one does is it port forwards. So what that means is when you create a Jupyter notebook or a Jupyter server, it will automatically by default bind to port 8888 on your computer or on whatever computer you created it on. In this case, our Jupyter server is inside of a container, which is a Linux machine. And so we want to mount or to create a connection between the Jupyter notebook and the containers port 888 and our port 888 on our own personal machine so that they can communicate and we in our browser can see what's happening in the container. Yeah, there's a little bit more with networking, but you can look more into it if you're curious. -v, what that's going to do is it will mount whatever the first directory you say to the second directory you say. So here we're running a bash command. So this $pwd, what that does is it stands for print working directory. And it will get whatever your current path is in your terminal. So that's the difference between Mac and Linux and Windows is just it's all caps versus lowercase. But what we're saying is we want whatever current directory we're in, and we want to map that to the directory, this directory inside of the Jupyter notebook in the container. This home Jovian work is just a default contained or structure for Jupyter notebooks when they are created. And so you'll be able to, and you'll be able to see that once we run this command, you can see the directory structure that's created. inside of the container. And then last, you just specify the image that you actually want to run. And then after we do all this, you should get a bunch of this stuff spit out. And it looks kind of scary and confusing, but what it's saying is that it's starting a server, it's allocating resources, and then yours will stop about here. Yours won't have any of these logs under it, but yours will stop at the bottom. And if you Control or Command click on this bottom link, it'll open in your browser to a Jupyter notebook. And it should open just to this work directory, which is the one that we linked. So we linked work, or the Jovian, the whole path that we got to get here. So now that we've got a Jupyter notebook up and it's running in our browser, it's working. Oh, also, I should specify, you might, instead of getting this Jupyter notebook window to pop up, you may have a pop-up window of saying that you need a token in order to start a Jupyter notebook. If you go back to your terminal, it's included in the URL. So you can copy paste this token at the end into your own code, and it'll have a little box on your screen to put it in, and it should let you in after that. But now that we're in, we can go in and we can go to this test Jupyter notebook that I created. And so in the process of doing this, right, we never installed Python. We never installed Pandas. We never installed any of these other packages. But inside of this notebook, we can run all, and we'll see that that Pandas is importing without error. Python code runs. And we can use Pandas functions in order to do data science work. Yeah, and that's the power of Docker in a nutshell. Is we never had to install any of these. We only had to install one image, and we can then do all of our work in here and tell someone else that they just need to install this image, and all of our work will work exactly as it did on our computer on their computer. But yeah, that is the gist of Docker for data science. If you want, this tutorial goes a little bit more in depth about if you want to build your own image, it talks a little bit about it, and sharing containers and images after you've built them. There's not enough time for me to go in and talk about all of those, but if you are curious, it is in the GitHub link, and I will post that with this video. So I hope you enjoyed, and if you have any questions, shoot me a reply on the discussion board, and I'll catch you later.